Well, hello, sixth grade. I hope you're doing well. Today we're going to look at an idea that we've already had pretty good experience with. Formulas. And formulas are basically a mathematical equation. It's an equation that shows the relationship between variables. We use formulas for different things, and then obviously substitution, because basically what we're asked to do is evaluate, and when we evaluate, we always substitute. Do you recognize this formula? Usually this is the first formula that kids are often introduced to in its early grades, is maybe second and third and fourth. Hopefully you do. This is called the kind of formula for distance, but there is a different geometric formula for distance. So I don't want you to call it the distance formula. We use these for motion problems, right, and stuff like that. So D obviously represents our distance, R represents our rate, that's our speed, and then T is our time. So what they would do is give us something to substitute in, but I want you to write down just so you make sure, because this is my expectation of you. When substituting, we always use parentheses. And so if they said, go ahead and substitute D equaling, let's say, 36, and R equaling 9. Again, they're kind of removing that this is connected to a real-world idea. We'll look at real-world in just a moment. But what I would do is go, okay, so I'm going to plug in for my D, I'm going to plug in that 36 and use those parentheses as I've asked you to do so. And then the R, we're claiming to be 9. And then the T, we don't know. So basically, we're going to find out what our T is. We've had good enough experience in algebra that I should ask you what's happening in your variable. Well done. It's being multiplied by 9. So what are you going to do in 5 words less? There you go. We're going to divide both sides by 9. And then ultimately on the right side, 9t divided by 9, we know would just be t or 1t. And then 36 divided by 9 would be 4. So again, this is us using the formula, but not really in a real world capacity. And we do want to get into that. So let's dive there now. Please write the statement down. It says, Anthony traveled for 2.5 hours at 60 miles per hour. And that's a fact for Anthony. Here's our question. What was his distance? And again, we want to use that D equals RT for these situations. And so I'm always going to start with that formula, D equals RT, because that's what would meet this real world situation. Then we got to think about the information they gave us. They said, hey, what's the distance? So again, that's the thing I don't know. That's my D for distance. And then it says travel for 2.5 hours. So again, that's a time. When we talk about time in this realm, we're not talking about like, oh, I'll see you at 8:30 or oh, I woke up at 6 a.m. We're talking about duration, like how long something took, such as 2.5 hours. And then the 60 miles per hour is a speed, but we often refer to that in this case as a rate. Rate and speed is the same thing. So when you're like, speed up, Dad, you're only going 20 miles per hour, or slow down, Mom, you're going 90. Those are speeds, but we call them rates. And then I'm going to go ahead and plug in. So the D is remaining the same. The R that they gave me is 60 miles per hour, and that's a rate. So we're going to write that out, miles, and then we'll place that over hours instead of MPH or something like that. And then the T, they told me, is 2.5 hours. Now, in a recent lesson, what the heck? Why is that taking so long? That's weird. In a recent lesson, we saw that we're able to cancel units. Well, so this hour and hour, I'm able to cancel out right now. And then I'll rewrite my statement that D is equal to 60 miles. And then remember the crucial first step. Whenever I multiply mixed numbers, I have to turn them into improper fractions. So 2.5 would be 5 halves. I had a nice cross-canceling opportunity here with the 2 and the 60, the 2 becoming a 1, the 60 becoming 30 miles. And then I just multiply straight across. D is equal to 150 miles. And I can box that up because that answers his question of what was his distance. How far did he travel, if you will? Yeah, that's Anthony. Let's talk about Alexandria, who biked 64 miles in 4 hours. Sounds like a lot, for me at least. So again, the question is, what was her average speed? Speed being that rate. And so I'm going to look at the key information they give me, but remember, I am going to use this formula every time. So D equals RT. And then think about so 64 miles is what? Well, if I said I traveled 64 miles, what is that? Clearly a distance, right? And then this 4 hours, well, that's a duration of time. So the 4 hours is my t. And then I'm going to plug in to find out her average speed or her rate. So d is equal to 64 miles. R is staying as R. We're using parentheses. T is equal to 4 hours. I'm going to ask myself what's happening in the variable. Hopefully you would answer it's being multiplied by 4 hours. So what are you going to do? I'm going to divide both sides by 4 hours, right? Because we're able to do that. And then finding out her average speed, which we know to be her rate, I know I get the R. And then the 64 miles per 4 hours, well, that can be simplified because 64 divided by 4, I know to be 16. And then I could say 16 miles per hour or 16 mph. What was her average speed? 16 miles per hour. And actually, I don't know if that's fast for a bike. Sounds fast to me, especially to keep it up that whole time. That's awesome. Hey, let's look at this situation. I'll give a sticker for anyone who could tell me what this is. Nice! So this is when we convert from Celsius, where the rest of the world is living in weather, and Fahrenheit, where we Americans decide is the best way. And so what we can do, if we're given a Celsius degree, such as C is equal to 37, which, oh my gosh, that sounds freezing, right? We can plug it in to find out, well, what is that in Fahrenheit world? Because I really don't know Celsius because I'm American, right? So if I plug it in, again, using parentheses for that C, I'd say F is equal to 1.8, open up some parentheses, drop in the 37 plus 32. Now, there's no way I know what 37 times 1.8 is, so I'm going to go ahead and set that up. 37, 1.8, 1/8 tenths. 7 times 8 is 56. That's my favorite one. Carry the 5. 3 times 8, 24. Plus the 5, it's 29. I tag the 0. 7 times 1, 7. 3 times 1, 3. I'm going to go ahead and do some adding right now. So I have 6 plus 0, 6. 9 plus 7, 16. Carry the 1. 2 plus 3, 5 plus the 1. Oh, so, that sounds like a scary number. And then remember the decimal thing, chicken wing. So I know that F is equal to, and I'm going to drop in that value, which I don't really even like seeing on our board. Oh, Lord, let's get out of it quick. So 66 and 6/10 plus 32, I should be able to kind of mentally do that. If not, I should line up my decimals and get it right and end up at 98 and 6/10. Again, this wasn't connected to a real world situation, but this is the exact formula we would use if we have our Celsius and we want to convert to our Fahrenheit. So actually 37 in their world is brutally hot because when it gets 98.6, this is definitely time that we're rolling out to the beach and such like that. Yeah. So I feel like we've done all this stuff before. So just asking you to kind of gauge in it again. L93, so that means we'll do homework 93. Makes sense to me. Hope you're doing well. You can reach out to me anytime. Goodbye.